It's been a few years now since I went out and I bought my very first air compressor, and I thought everything was great. Got my tank, got some hoses, just for general duty, nothing special, until I saw the damage, and then I realized I was missing an absolutely integral part of a compressed air system. Hello everyone, welcome back to the channel of Figure It Out. If this is the first time you're joining, welcome to you too. Hi, my name is Steve. Now usually here on the channel we work on Audi's, DIY projects, maintenance, cool stuff like that, but once in a while I like to sprinkle in a little bit of shop updates too. And we do have an improvement to make in the garage here right now to make our air compressor system up to snuff, what it really should have been before. And you know what? I'll bet you have the same problem that I do too, and you just didn't know it. You're probably in one of two camps watching this video. Either one, you're designing a shop air system, which is absolutely fantastic because it is not too late for you at all to just design it to the nth degree, make it absolutely perfect, exactly for your needs. And then the other camp is probably like me, where you've been using compressed air for a while, but you have not put an inline air filtration system in, which is exactly what you need to have. And you know what? Don't blame yourself. I don't blame myself for not knowing about these filtration systems. Chances are when you bought your first tank, it was just based on price, right? You just saw something that looked like it was going to fit your needs. The price was right and you brought it home. And you probably did it at a big box store where there was absolutely nobody to talk to. And even if there was someone, they probably didn't know about this. So it's sort of just a big game of ignorance, and you just learned this by mistake. However, I really wish someone, and I went to KMS Tools at the time here in Edmonton, and I actually did talk to somebody, and I really wish that person would have said, hey, you know what, I can tell this is your first time setting up an air tank and using air tools and stuff like this. You know, we have a lot of humidity in the air that we breathe, and that's the air that goes into your tank. And did you know that you really want to remove as much water as you possibly can out of those lines, because it's just simply bad for your pneumatic tools and for other purposes you might be using it for? You really should filter that air. That would have been really useful. Run out to the garage really quick after I say this and check your main air line if you're just running a tank and like a single 1/4-inch NTP hose or something like that. See if you have the same problem that I found. Check this out. So I popped off the main connection at the quick connect on my tank, and look at what I found. Look at the corrosion on the end here. You got to keep in mind that when you're not using brass and it's so-called aluminum, they're really just aluminum alloys, meaning it's not pure aluminum. It absolutely can rust and corrode. And let this be evidence that it can. This is what happens when humidity is inside of your lines. So when I found damage on both ends of my lines, I went into research mode right away, spent a whole bunch of time reading online, and I started to get the basics. At first I was overwhelmed because there are a million ways to do this, essentially, especially if you're like a really big shop. If you are a commercial complex or you have some industrial tooling needs, you know, this is not going to be the video for you. What I want to do for you is basically summarize the information that I have and show you how to design a system that will not break the bank, that you can easily apply to a home enthusiast garage like mine, or a small shop that has really no filtration set up right now and you just need to get something going. And although I think it's pretty obvious at this point, yeah, this is my first time designing and building out a system like this. I am not trying to be a know-it-all definitive guide online for your shop here. I'm not pretending to do everything perfect. In fact, there's a few corners that I have explicitly decided to cut today that I'll talk about later. But this is just to build awareness that there are other parts of an air compressor system that you should be thinking about so that you can figure out how to execute it to your standards in your shop. I'm going to get into all the components in a second here and we'll start looking at the design of my system, but I want you to just pause for a second and think about what are your goals? What are your needs in the garage? What's going to make your life better? Because you need to start with the outcome in mind. For example, I have 3 goals in mind for the garage here. Number 1 is just general purpose. I want to be able to reach up and just pull down an air line that I can use for general purposes. I'm talking about cleaning, filling tires, and maybe for some light automotive uses like pressurizing bleeder systems and stuff like that. Number 2, I now have some basic pneumatic tools in the shop that I want to run off air. So I'm talking about like little rotary grinders and air hammers, stuff like that that's going to need compressed air to run constantly. Finally, the last one is something that I probably won't use super often, but I'll be very glad that I plan to head for, which is painting. So I'm talking about when you need to use compressed air to shoot out paint that's being top fed into just a little trigger gun. Bonus points to you if you were just listening and said, you know what, all 3 of those purposes sound like they have different requirements for the lines, which they absolutely do, which is how I designed my system. So let's get into that finally. Also, rest assured that every single item that you see me use today is available on Amazon, and I've put an entire list of what my inventory is in the description of the video for a link out to Amazon so you can buy it yourself. I'm sure you've caught on by now that water separation really is the name of the game for airlines. Some of them have some special needs though, which is why I have this extra little setup right here. This is going to be for my dedicated pneumatic tool line, because this particular filter on the side is actually going to introduce lubrication into that line, which is what a lot of those tools need. You would have had to lubricate the tools regardless, but it makes your life a whole lot easier if you actually just put it upstream and then slowly feed the tools oil at all times. Otherwise, we have a air-water separator and desiccant filter for the main line, and then we have an additional air-water separator for the painting line. For reference, before you see the design, I have my tank under my workbench right now. That's where it's going to stay. And I've elected to run my entire filtration system up on this unused section of wall. I think it's going to look kind of cool and clean up there, but also to a certain degree, it'll be concealed and just a better look in the garage as a whole because you won't be able to see it across that edge. The reason I just showed you that is because I'm encouraging you to actually do a paper design first like I did. I used a tool called Miro. It's a free, basically like grid tool that you can kind of just plan whatever you want in, draw some pictures. I found it very useful that once I actually picked my filters, I could actually go ahead and figure out, well, how am I going to run my lines in that particular space? How many fittings am I going to need? Really helpful for planning. One thing we need to address here is what to make the lines out of. In all of your searches online, you will be correctly recommended to build the lines out of something that is hard, so like not a flexible rubber hose. And I'll talk about why it's beneficial to do that in a second, but the material options are going to be varied and many, and it's going to be something like aluminum or copper or black piping, and pros and cons to all those different things. But ultimately, I had no intention of spending more than a couple $100s here on fittings and the lines themselves, and I did achieve that, but depending on your decision here, it could blow the budget out of the water. One of your decision inputs into what material to choose though is how much PSI do you need to run throughout the lines in the system. My needs are not that high. I'm choosing to go a 3/8 system here, but also keep in mind that every time you neck down, you are limiting the total airflow that goes through the system. And what I mean by that is although my port size on a lot of the components I'm going to be showing you today are 3/8, a lot of the fittings themselves are 1/4 inch NTP. So that is going to choke down the flow. If you have some big boy pneumatic tools in the shop that needs a lot of constant airflow running through it, you might be looking at an entire 1/2 inch system, for example. But just know that every time you bump up the size of the fittings there, ultimately your cost is going to multiply because of all the filters are going to get bigger and the lines are going to get bigger and all the fittings get more expensive too. So keep it in mind. While you think about your project needs, allow me to provide a simple breakdown of common airline materials and address why any type of hardline is likely better than continuing to run rubber lines to distribute your air. I know it may be tempting to just run multiple rubber hoses together with a few connections between them, but that is not a long-term solution. Rubber is easy to work with and find on local store shelves, but you'd end up spending more than you think to plumb a shop. The inner surface actually helps build up condensation more than any other hard material, creates pressure drops, and actually breaks down over time. Black pipe would seem like a great option just because of how tough it is, but truthfully, this may be the worst material to choose because of long-term degradation since it easily rusts and corrodes. Both copper and aluminum piping are similar in the sense that they aren't too hard to work with, they're a great option to avoid corrosion, they're lightweight and good at shedding captured heat, but both are still quite expensive to use for an entire system. For a home shop, these materials are still likely overkill. Probably the best modern all-around choice is flexible aluminum tubing that's wrapped both inside and out with a layer of HDPE plastic. Although still a notch above the entry-level enthusiast option that I picked, it really offers all the best attributes a person could want out of an airline. If you have a medium or large shop and don't mind spending over $1,000 on your entire system of lines and fittings and filters, this may actually be the one for you. Last, a selection of common plastics. PVC is dirt cheap but will very likely explode due to its lack of strength, and it is not an allowable material to use in any inspected shop. PEX is a common tubing used for many applications in construction, and to be fair, people have had plenty of success using this for airlines as well. Technically though, it's a product designed to carry liquid. It is not meant to hold more than about 160 psi, and the fittings required to plumb joints are a little expensive. And finally, the option that I'm using, TPEE, which if you're really interested to understand how the molecular composition differs from PEX, just Google it, but it's basically an engineered plastic very suitable for airlines. It's cheap and it takes zero real skills and tools to install, plus it accepts push connector fittings. And just so you know, for the rest of this video, my tank is always regulated at basically 150 psi, or certainly no higher than that, which is great because it means that I don't need some crazy hardcore line solution here. I can do something a little bit more entry level that's still going to absolutely work up to 150 psi. Dollar for dollar, there was no better option in my searching than this Primefit kit. Primefit product line is basically all about plastic tubing, and push connectors. So when you build your lines, you actually just get to pop them right in here. There's no like threading of brass fittings. I definitely have brass fittings for certain parts of it, but when it comes to actually creating your lines, it's just a cut and a push, and then likewise you can pull them out really easily later. You'll get a sense for it when I actually start building this later in the video, but as an entry-level kit that costs barely over $100, this is great value. The absolute essence of this kit is really just 1/2 inch outer diameter tubing that goes into push connectors that always have a threaded end of 3/8 NTP. Let's also quickly address the temperature versus condensation battle that will always be happening within your airlines using this very handy visual provided by Tsunami Compressed Air Solutions. When air is compressed, it will heat up, and when air is hot, it tends to retain its water content more so than cold air. In other words, the likelihood of condensation occurring in your air system is higher the further it is away from the compressor. And this is why it's recommended you provide at least 25 linear feet of line immediately after the tank and before your first quick connect. This distance gives the time and surface area needed to expel the heat and prime the air to let go of its moisture at the first capture point that you create. In this visual, that happens in the first drop leg with a drain valve. Note, the tank itself also should have a drain valve. A popular, albeit expensive and space-consuming method of shedding heat after the tank is creating what is essentially a radiator out of copper piping, which itself can contain the first drain port in your system. Also notice that heat radiates in both directions of the compressor if you have a continuous circuit on your main line. Last, and remember this for later, your system can also incorporate risers that further encourage water separation right before the air enters a set of filters and an air access point. And because I've already done my design, I know exactly what needs to go where. So let me do some pre-assembly on the bench. I'll show you a couple more things and then I'll put it up on the wall and we'll take another look. A few hours of just kind of threading things together in a nice peaceful setting out in the garage. We have something like this. One thing you have to keep in mind about the filters is that they typically are directional, left to right, which is kind of annoying for me because my air source is coming from the right and I actually want to move left, which means I'm actually going to wrap it around and come back across. Which is why it's laid out this way. So I'm going to come in, I have an extra ball valve up here so I can shut off all the compressed air to the entire system if I want to. And then I come into my first round of filters. So all air gets air and water separated and dried again in the secondary filter right here before it hits my manifold. At that point, it splits off into my 3 dedicated lines. The first one has no additional filtration. This is just going to go out to my hose reel that's going to be sitting up onto the ceiling. And it's actually kind of nice because when you buy the kit like this, it has a little 45-degree elbow right here to actually pitch off the quick connect in a more efficient way to get at it with your air fitting coming in. Then the second line goes off into my extra separator and regulator, which I'll actually regulate down like I was talking about earlier for my smaller tools. And then the lubricator, which I'll fill up with oil later. That goes to, of course, its own exit point. And then I have my third line that goes through yet another air separator with its own outlet for painting. One thing I want to talk about is how I actually sealed all these threads, because notice this white goop that seems to be coming out of every single joint. Well, I didn't use any Teflon tape anywhere in the system. This is the product from Permatex that I went for. There's your part number right there at the bottom. I've had a lot of success using this in the past in automotive applications actually. And you might not think that a product that never dries, because this doesn't dry, it stays in sort of like a pasty state at all times. You might not think that it could seal threads and hold back high pressure air or other pressurized liquids, but it actually does a fantastic job. We'll see what happens here in a little bit once we set up the system on the wall and pressurize it. We'll make sure we don't have any leaks, but I have a lot of faith in this. There are 2 things I want to call out about the outlets here. One is the plug on the back. So there is, for some reason, a 3/8 plug on the very back, which I truly couldn't understand what this would be used for. I would have loved it not to have been there, because if you look at the back profile and I put this up against a wall, it's not going to be even. So I need to figure out how to space the screw connections on the back here so that it's nice and stable. But maybe this is for a different type of configuration that you can use. It's just weird because the front port is 1/4 inch NTP, so it can fit up to your like pretty typical air fittings. Maybe you could flip it around and do a reverse. The other thing is this does not come with a 1/4 inch plug. So it's not like they're giving you an option of use the 3/8 or the 1/4 inch. They're basically saying use the 1/4 and I don't know, plug this. I really don't know why that's there. Seems pointless. However, a really nice bonus is actually just the drain on the bottom. That's what this is. So being that this is going to be at pretty much the lowest point on the wall, so all 3 of them will be right up on that edge, they will collect a little bit of condensed water that makes it through the filters upstream. So I can, at the beginning of a session, I can pressurize the system and just go crack, 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 drain all the air out, close them up again, and off I go. Meanwhile, with recommendation from Primefit, I actually just hung up the hose so it can actually sort of just relax for a little while. We can always apply some heat to it to make sure that it's straight when we're trying to get it into our connectors, because that is very much the next part here. We need to start building some lines, so let me show you how to use these. Before we talk about the fittings themselves, I just want to call out the fact that you need to be sure that you can cut your piping with very, very high precision so it's super flat on the side like that. No jagged edges, because if you push it into the fitting and it isn't even, you're not going to be able to hold air. And this should be really easy to do with what the kit gives you, which is this really simple cutting tool. There's a little groove on the top that's curved so it can center the pipe within it. Nice sharp blade, you get a nice flat cut every single time. Such that when I'm done cutting all my piping, you simply just press it straight in. That was truly it. There's little claws on the inside of the fitting here that hold it into place. So I'm pulling right now, nothing is coming loose. However, if I want to take it out, I can actually just find the little oval edges of the fitting, put my fingers on it like so, pull back, and now I can release the tube and just try again if I want. You're probably starting to see the benefits of running a kit like this where you have push connector fittings and somewhat flexible hose lines. Is it gives you room to screw up essentially. If your lines are too long or too short, cut it, try again, get a new one. And with, let's just say, a 90-degree fitting, if that was a hard pipe, if I have a threaded portion on my pipe where I want it tight, well, all of a sudden my 90 degrees might be like clocked in an area that I don't want it. Whereas with these push connector fittings, even though I can pull in and out for the piping, I can also rotate that fitting any degree I want on the pipe it's already connected to. So if I need a little bit of leeway to sort of pull something over here, it's no problem. And with that, it is installation time. I'm gonna throw the camera on a time lapse so you can see my work. I have no doubt this will take a couple hours for me. I'm a pretty picky person when it comes to final installation. I want it to be just so I've got some extra hardware I need to go get to make sure everything's mounted to the wall really nicely. So you enjoy, and we'll take a look at it when I'm done. As you could have guessed from the multiple wardrobe changes and now the facial hair, yeah, it took me a couple of days to get this fine-tuned exactly how I wanted it, but it really did come out exactly as designed. I knew using the push connectors were already going to be an advantage because of course you can swivel them on the line 360 degrees, but I didn't account for how useful that was actually going to be because after all, your hose, albeit flexible, does come pretty tightly wound on the reel. And I did use my heat gun to sort of warm things up when I knew I was going to be doing a run that was going to be totally flat. And I was just trying to get rid of some of that curve. But that memory in the line is always going to be there. And that's okay because this is a great example here on the manifold where you cannot get the lines hard against the wall because they have to go out first, right? So we've got a 90 straight up and I'm dealing with maybe 3 inches right here that needs to be accounted for somehow. So you can actually account for that with your line and leave it a little bit curved to naturally come up off the wall. Obviously take your fitting, swivel it over about 45 degrees and just accept that incoming curve. And that's going to happen everywhere. You're not always going to be flat against the surface. Some connectors are going to be, maybe ½ an inch away. Some are going to be very far away, some sort of medium, and you have lots of flexibility when you use a system like this. I've also added sort of the key feature of why I did this in the first place, my hose reel, so I can walk around the garage and get air as I needed to. In this case, I can just jump up. It's retractable, locks in like so, walk around when I'm done, send her right back up. So earlier I mentioned I made some choices that you might not want to do, and this is definitely one of them. I have decided to put a single shutoff here. Now, an improvement you could make, and I simply just didn't want to invest the time and money to do it on all 3 lines, is to do just that. So for example, you still probably want to have a main shutoff coming from the tank, but then you also want to have one per line. So I would go after the main filters, after the manifold, and I would probably put one right here so I could shut down just this line and put another one in here somewhere to just shut down that one. Likewise, I could do it for the hose reel as well. One thing I did not do was add what's called risers and drop legs for water and air separation before any of the filtration. So right now, let's use this line as an example. Off my manifold, I simply have my separator, regulator, and lubricator, and then a single drop leg into my hookup point and my single drain point. So once in a while, for whatever doesn't get captured in the separator or the one up here, I will want to vent this, right? So once in a while, I'll charge up the entire system, and on all of my connection points right here, I'll throw this valve, drain a little bit of water, and that's it. However, if you want to do an even better job, up here, what I would have done is actually teed it off. So the down portion would go to yet another ball valve that I could drain, and then the actual air itself would go up and then come into here. So you're always separating water down, air up. And I think pretty obviously for my setup, because it's so small, I simply don't need it. There isn't enough length of hose here for more water to build up after the dryer and before it gets to the next drain point. But for you, and honestly the way that this kit was designed, it's meant to plumb basically a small shop. Like if I had a workstation way over the corner where I have one drop line and then a huge length of line all the way out to the other side where I might have another workstation, yeah, I could see a riser and drop leg section being really useful for something like that. Not for me. So obviously use your brain, figure out what makes sense for you, and design your system accordingly. Another small thing that I did that I might recommend you look into if you're putting it onto a surface like this is, remember, there's a brass port on the back of this outlet that holds it off the wall a bit. I picked up a pack of about 50 washers, and I put 2 washers behind each screw here just to make sure that it's totally level on the wall, wasn't wobbling around or fixed unevenly. Just looks good. It's time to do the part that I was dreading because I really don't want to take anything apart, but chances are there's going to be a few leaks somewhere. Just got some soapy water here. I'll pressurize the tank, obviously, give it a couple of sprays all around the joints, anywhere where I put that sealant, and let's see if we have some air coming out. It doesn't leak at all. I don't understand. I flipped the valve up there. I've got 150 PSI sitting in the tank, and you can hear the thunderstorm that's outside coming around, but apparently I did a perfect job. So moving on. While the system is still pressurized, this gives me an opportunity to show the automatic drains, because once the system here has no pressure in it, there's actually relief valves on certain filters, like this one certainly, where once the pressure hits 0, it'll automatically drain any water that's in it. So not that there's any water in there now, but listen to this. Water off, or I should say pressure off. I'll use this to empty the air in the system. Probably heard those little pop, pop, pop. That's all the automatic drains opening. And maybe that's a good little heads up for you, depending on where you mount all these things. Water will be draining out of those automatic drains. If you really wanted to, you could connect little hoses to the bottom of it so that when the pressure does hit 0 and the water comes out, it actually flows to a receptacle somewhere that you've put away on the side, and then you drain that once in a while. Otherwise, like for me, for example, water's gonna be falling on my head, so I just need to watch out for that. Maybe yours will be running along a wall where there's drywall. Maybe you want to watch out for that. So just think about it once again. Now, obviously in this video, I haven't spent a lot of time talking about the individual filter components because truthfully, I don't know a ton about them. I know what they do, but I don't pretend to know exactly how they work or what type of filter elements are inside and all the specifics. But I can say for sure that if you have a desiccant filter, you obviously need to put something in them, and likewise with the lubricator. Inside the desiccant filter, you can see all my beads are loaded up. Typically in a good kit, they'll give you basically 2 batches worth because these do consume water pretty quickly. You'll see them turn pink, and at that point you either need to dump them out and just let them air dry and in the meantime reload, or put them in the oven when you're cooking something else out. Either way, let them dry before they go back in, so make sure that they're blue. Otherwise, on a nice kit like this one, I also have an indicator light here letting me know that the filter needs to be serviced. When it comes to the lubricator on side of my pneumatic air line, basically I'm just going to be filling it up with air tool oil, exactly as you would service your air tools with in the first place, but you're simply adding it to the cup. Up on the filter system itself, on the lubrication end of things, we have yet another little filter, and we're basically just using the air itself to create a low pressure zone as it comes across into this tube to help suck oil up out of the little reservoir there. And so I'll keep my eye on that over time too and see how fast it goes and make sure that we keep it filled up. So somewhat surprisingly, I'm done. Everything worked just fine in my testing. I'm not really used to doing a project and actually it working completely for the first time without having to redo something. So I must be getting kind of good at this. Anyways, thank you so much for watching. If you end up buying this kit and applying it in a similar way that I did, and you had some insights and you want to share them with the community, please absolutely come back to this video and tell us about your project and what kind of changes you made, or maybe parts that I did in my system that also worked really well for you. Any type of feedback like that is very much welcome. Again, thanks for watching. Subscribe, like the video. Hope to see you next time. See ya.